Hello class, what we're doing today is we're going over while loops. So we know for loops, now we're going to be doing while loops. So, funny jokes, one does not simply leave a while loop. And then, yo dog, I heard you like loops, so I put a loop inside a loop so you can loop while you loop. So my favorite joke though is, a wife calls her programmer husband and tells him, while you're out, buy some milk. He never returns home. What that means is, while you're out, are you out? True. Go buy some milk. While you're buying milk, are you out? True. Go buy some more milk. While you're out buying that more milk, are you out? True. Go buy some more milk. And it repeats, and repeats, and it repeats. Anyways. So I like that one. Anyways, what we're doing here is we have for loops on the top, we have while loops on the bottom. All of you know how to program for loops, hopefully, or at least tried to before. Now, most teachers, keyword teachers, teach while loops first. Now, while that's an okay idea, what I want to teach was for loops for this exact reason. See what I did there? Yeah. Anyway, so for loops have everything in this one line. So you can't mess up where it goes, because all of them go right there. Whereas while loops, they have a line here, they have a line here, and they have a line here. And you can take this line, put it here, or put it here, or put it here, and you'll get a whole bunch of errors. You can also take this and put it here, or put it here, or put it here, and get a whole bunch of errors. Whereas in the for loop, it has it all set up very nicely. Now, first thing we're going to do is we're going to match up everything with everything. So, right here, every single character that's up here is down here. The only difference is a for and a while loop. Those characters are the only difference. For example, we have int I equals 10 with a semicolon. Int I equals 10. Semicolon. Now you may ask, why do I have XX there? I have XX here because it's just a variable name. I can name it YY, I can name it Nate the Great, I can name it Happy Days at Forest Park High School, with no spaces at least. As long as there's no punctuation or spaces, it's pretty much a good variable name as long as it doesn't start with a number. Otherwise I think it's a number. Next part we have is the conditional. Stays where it's already at. Next one we have, which I'm going to move this basically to the end, is the counter. And the counter is right there. I then have the parentheses, which are right there. And I have the squirrely brackets, which are also right there. And then last but not least, the print line is the print line. If you notice, every single thing that's in a for loop is in a while loop. The only difference is literally the word for and while. So the next thing what we want to realize is, how do I get from a for loop to a while loop? First thing you want to do is take the integer part of the code and bring it up to the top. Next thing you want to do is take the decrementer, or the counter, and move it below the print line above this squirrely bracket. So let's just move that down a little bit. The next thing you want to do is, instead of for, make it a while loop. That's it. The best part about this is, I'm going to have you do this for a grade. What you're going to be doing is you're going to be taking the for loops assignment and turning them into while loops. What that means is I'm going to be grading you on copy, pasta, change, type. Move on to the next one. Why does this happen? And what errors are you going to run into? In the for loop, what we have is everything in place and the print line. It looks very neat. The while loop is scattered. Does everyone see that? Most programmers use for loops just because it looks neater. They look smarter when they use it, even though it's the exact same code. if, oh man, if we take this integer and put it inside here, we have a compile error because I'm using a variable and then declaring the variable. What we're talking about here is 1, scope of the variable, 2, compile error of declaring a variable inside a while statement. Next error we have is if we declare it at the end. Well, that's not going to work because, again, we're going to have 2 error messages. Basically, it's going to still be the same error message. The third compile error you're going to have is double declaring variables. So if I put this int I equals 10 right up here, and I declare it again int I equals 10, it's going to say variable already declared. It's going to give you a compile error. If you go like this will compile. See how I took out the int part to the XX? So I declared it up here, and I just changed the value down here. You can do that. So what he's saying is he wants to use one variable for multiple loops. To do that, you just don't redeclare it. You don't have the int in front, and then you can actually still use the same variable name. The other error you're going to get is if I move this up here, it's a logic error for one. The question is, why is it a logic error? Well, let's see. If we take this, I'm starting out, x is 10. I decrease xx, it's 9. I go into the loop, is 9 greater than 1? Yes, it is. I go through and I output 9. And then I loop back up. Is 9 greater than 1? Yes, it is. Output 9. End of the loop. Go back up. Is 9 greater than 1? So we have an infinite loop of always printing out 9. So that's not good. That's one way you'll mess up. The other way you'll mess up is you'll put it here. You want the loop 10 to 2. This is going to print out 9 to 1. Because realize, starting out with 10. Is 10 greater than 1? Yes. Decrease xx to 9, output 9. 9 greater than 1? Yes. Decrease, output 8, ... 2 greater than 1? Yes. Decrease 2, output 1. Is 1 greater than 1? No, don't go in. But I already outputted 1. So that could be a logic error. It doesn't necessarily have to be a logic error, because this could be my goal. Output 9 to 1. Please realize, what I want you to do is learn the format of these while statements. The best way to do that is to not program new while statements, because then you're learning how to do more loops. What I want you to do is to see the difference between a for loop and a while loop by taking your for loop code and changing it into a while loop code. Now, before I let you loose, there is a double while loop code on Box. The one issue with it right now is I don't reset u back to its original value. Actually, I do. It's right up here. Sorry. But let's look at this for a second. This is a nested while loop. Let's take the nested for loop. We have the nested while loop and the nested for loop. Let's take a look at this. We have, first out is this right here is really, really important. It's not going to be on the test. But what it's doing is I'm taking my print line, sets of code, and I'm saying while below, which means, or I'm just typing in anything, so A, B, C. What happens here is when I run the code, when I run my code, I want to fix this loop right here. To do that, I say I put in a little text bit right here. Fix that lame code. Now when I compile and run it, does everyone see? I instantly see the output for that specific line. Where is it? 3915, right here. Fix that lame code and output. Fix that lame code and output. I instantly see where I'm working at. The next one is, so this is a great debugger tool. Let's take a look at the next one. First thing I do here is declare RR. First thing I do here is declare X. So that's 1. Then what I do is I check the conditional right here. I check the conditional, which the numbers aren't the same. Please realize that. But it's the same step. Next thing I do is I declare, different color. I declare U. I declare I. Same step. Next one I do is I say while U. I say while U. Next thing I do is I print out UU. Inside here, I print out UU. Now what happens is I go to the end of this and I go back up in the for loop section. Here, I increase U. I increase U. Over here, I increase U. Then I go through it again. So now I loop back up and reap output. Once I'm done with this one loop, I go on the outside and I do my end line. Here, I do my end line. I increase my X. After I'm done here, I go back up and I increase my X. And then I repeat. And then I repeat. The only difference here is this int U right here is huge. What this int U equals 1 does is, oh man, it resets this variable. So when I re-go through this loop, I get this back to U, and I redeclare it. Now, some of you may be thinking this is a compile error because I'm redeclaring a variable. However, the scope of a variable means that this int UU only exists until I get to here. And once I get to here, it is deleted from memory. And then when I go back up, I create a new instance of this UU, but it's a completely new value. The same thing happens right here. Every time I rerun this, I gets reset to 4. The nice thing about the for loops, when I taught you this, it all happens in the background. Over here, if I took this code, oh man, there's a whole bunch of stuff here, and move this up here, I'm going to show you what happens. So we have in BlueJ, maybe we don't. So unbox, if you want to get to this code, what we're going to do is go to Student Computer Math. You're going to go to Student Computer Math folder. You're going to click on Loops. And what I did was I already uploaded the Java file, and I also uploaded the PDF for all the notes for this assignment too. I'm going to right-click, download the Java file. The Java file is going to pop up. I'm going to click on the arrow, click on Show in Folder. And then what I'm going to do is I'm going to drag this Java file into my BlueJ folder just by going like this. And of course I have that message. And then it pops up right here. And then what I'm going to do is I'm going to go down to my while code. Now, let's take this code. Well, let's see here. Let's go print line. And I'm going to say, look here. I'm going to compile and run this. And what we're going to do is we're going to look underneath the look here comment. Look here. It says 1, 2, 3, 1, 2, 3, 1, 2, 3. It runs 3 times and it loops through. And outputs 3 outputs for every loop through. Now let's go to this code. And that's the only thing we're going to do is move this right here. That's the only thing. So I'm just declaring all my variables up on top, which is normally a good thing to do. But watch what happens. The only thing that happens is it outputs 1 line of code. 1, 2, 3. The reason why this happens is I declare the variables to be 1. 1's less than 4. 1's less than 4. Increase R until R is 4. Print line, increase Y. Y is now 2, but R is still 4. I go back, is R greater than 4? Yes, increase Y, print line. Print line, increase Y, drop out. So nothing is then outputted after that fact because I never get inside this loop again because I'm never resetting R. If you do want to do it where you're declaring the variable up here, you simply just take this code right here and you can either put it here, here, or here. And then when you compile and run it with just the RR equals 1 instead of int RR equals 1, you get your 1, 2, 3, 1, 2, 3, 1, 2, 3. What I want you to do right now, your goal is to take one of these and make it into a while loop from your for loop. Don't start from scratch. Make it into a for loop, then make it into a while loop. So go ahead and do that right now, and I'll look forward to making the next movie. See you later.